Hey guys, Mr. Backerberg here. In this video, we're going to take a look at inverses. So the function defined by reversing a one-to-one function f is the inverse of that function f, and we denote that as f with a little -1 power. That means the inverse of function f. In this first example, we're going to look at making a table for a function and its inverse. So the function that we're going to be dealing with is x cubed, and I'm just going to make an x and a y table. I'm going to plug in x values of -2, -1, 0, 1, and 2. -2 cubed gives me -8. If I plug in -1, -1 cubed is -1. Plugging in 0, 0 cubed is 0. Plugging in 1, we get 1, and plugging in 2, we get 8. Now, as far as the inverse, well, the opposite of cubing something is doing its cube root. So we're going to look at making a table of values here as well. When we plug in x values, though, I want to be really careful about the x values that I'm choosing. Because I'm doing a cubed root, I want numbers that are nicely cube rootable. And so what I'm going to look at is actually these y values that we just got as our answers from the function f. So we're going to use x values of -8, -1, 0, 1, and +8. Now we're going to take those and plug those in. So if I cube root -8, I'm going to get -2 as my answer. If I cube root -1, I'm going to get -1. Cube rooting 0 will get 0. If we do the cube root of 1, that'll be 1. And the cube root of 8 is going to be 2. So if we look at the relationship here between the function and its inverse with those tables, essentially what happened is because we're reversing the function, the x and y tables got reversed. So for our function f, when we plugged in -2, we got -8. Well, the reverse of that would be plugging in -8 and getting -2 as our answer. Now I want to look at this graphically and see what that means about these functions. So in my y equals screen, I've got x cubed typed in as my y1. I've got the cube root of x typed in as my y2. And then I added a third equation in here, which is just y equals x. If I look at my window for my x min to x max, I've got it going from -5 to 5. Same thing for the y min and y max. When I graph that out, so that blue graph is my x cubed. The red graph is my cube root of x. And then y equals x is that black line in there. The relationship graphically with a function and its inverse is that they are reflections of each other over that line y equals x. So if we took this blue graph and rotated it around that black line in the middle, it would overlap that red graph. It's a reflection over that line. In this example, we're going to look at another set of functions. So for our function f of x, we've got 3 times x. And the inverse, well, the opposite of multiplying by 3 is dividing by 3. So we have x divided by 3. I'm going to graph these ones out on my calculator. So in my calculator, for y1, I've got the 3x. For y2, I've got x divided by 3. And then y3, I've got just that y equals x in there again. So if I hit graph, there's my lines. The blue line is that 3x. The red line is that x over 3. And then we've got that y equals x running down the middle. And again, the relationship between a function and its inverse graphically is that they're reflections over that line y equals x. Last example that we're going to look at, we've got the function f of x equals e to the x. Well, the inverse of e to the x is the natural log of x. So that's our inverse function. And again, we're going to look at these graphically. So in my calculator for y1, I've got e to the x. For y2, I've got the natural log of x. And then y3, again, I've just got that y equals x. Graphing those out. So the blue line is your e to the x. The red line is the natural log of x. Now our calculator shows the red line stopping here, but it doesn't actually stop. There's a vertical asymptote running along here. And as this red graph gets closer and closer to that vertical asymptote, your calculator has trouble drawing it. So this graph does actually extend down forever and ever. So again, we can see that this red line and this blue line are reflections over that line y equals x. That's going to be it for this video. Thanks for watching.